Hello, my name is Brooke Friswold, and I'm excited to share with you my research regarding the impacts of light pollution on wedge-tail shearwaters. So wedge-tail shearwaters are a native seabird on Oahu. They're really important for lots of reasons. They indicate the health of the environment, they're apex predators, and they also face human-induced risks both on land and at sea, especially in human-dominated environments like Oahu. They're of the order Procellariformes, which is actually the most endangered order of seabird. So I'm going to define a few terms here. So fledging is the act of taking flight from the nesting colony to the foraging grounds for the first time. During this fledging event, seabirds can become disoriented, distracted, and fall to the ground in an event called fallout. Once on the ground, they're susceptible to car strikes and predation, and hundreds of individuals fall out on Oahu every year. So the wedge-tail shearwater is the most abundant seabird species on Oahu, and also the seabird that contributes the most individuals to fallout every year, making them an excellent model system for this study. So a little bit how light pollution and fallout are related is that seabirds are actually evolutionarily drawn to light because they're attracted to the moon's reflection off of the surface of the water, leading them to their foraging grounds. In a non-light saturated environment, they can follow a gradient to these foraging waters. However, without that gradient to follow, they're pretty much flying blind. They circle until they become exhausted, collide with an object, and fall to the ground. So my study area is the island of Oahu, particularly the southeastern region, as this is where about 90% of wedge-tail shearwaters nest. So I indicated 5 main fallout factors, including light, and I analyzed all of them in this study to determine best management practices. So from 2002 to 2010, road surveys were conducted on the southeastern region of Oahu. For every fallout event that was discovered, a GPS point and an image were taken. And I analyzed 8 years of these images to determine if the fallout event occurred within 25 feet of an artificial light source or a power line. I also analyzed NOAA weather records against fallout recovery data, and I analyzed the lunar cycle against Rehabilitation Center intake data. All right, so also this year, we formed a team and got access to colonies through DOFA. And we actually banded 1,141 wedge-tail shearwater chicks from 7 colonies, which is putting a numbered band on the legs of the birds prior to fledging. Once they fledge, if they fall out, we can actually read those bands and determine the colony of origin, so where they're coming from. So here are our results. From 2002 to 2010, we found that fallout was slightly increasing with years of extreme oscillation. And I also found that of the 8 years of data and 377 images that I analyzed, 94% of fallout occurred within 25 feet of an artificial light source, 83% of fallout occurred within 25 feet of a power line, and virtually none around no fallout factors. I analyzed randomized points along the transect and actually found that the majority of randomized points, at 40%, were found to be near no fallout factors, indicating that this grouping of fallout around lights and power lines is not random. When you look at it spatially, we can see the northern and southern regions of the transect. Here we have light indicated as heat, and the northern region of the transect is where most of our colonies are, and actually where about 97% of fallout was found, indicating that lights in and of themselves aren't harming seabirds, just ones that are in close proximity to source colonies. When we look at it conversely with fallout as heat, we can determine hotspots for fallout, which in this case are Waimanalo and Makapu'u. When I looked at Rehabilitation Center intake data, I found that rehabilitation intake peaked exactly during the phase of the new moon. Of the birds that we banded, the majority of them came from Flat Island off of Kailua Beach Park, indicating this as a high-risk colony. So my recommendations for immediate management would be to focus our efforts on specific areas. So we don't need to turn off or alter lights on the entire island of Oahu. Just in these hotspot regions like Waimanalo and Makapu'u or near high-risk colonies, just during fledging season, so in this case November to January, and also during that new moon period, so putting it down to 1 week. If we hyper-focus our management efforts, we can increase the adoptability of these practices, lower the amount of money it takes and threats to human safety, and we can reduce mortality and fallout by the greatest magnitude possible. Thank you for your time. I'll take any questions.